and going to oxygen. Remember, if you want to follow the electrons and know where they go, you look at where the hydrogen goes, because the electrons always go with hydrogen. So here, electrons are leaving carbon and going to oxygen. So carbon is being oxidized. Oxygen is getting those hydrogens. So oxygen is being reduced. Oxygen here, because it's being reduced, is called the oxidizing agent. Carbon, which is being oxidized, is called the reducing agent. So this is a redox reaction. Yeah. Right here?
Yeah.
Oxygen's over here.
Oh.
But remember, even these oxygens right here are gaining electrons, because over here, the oxygens are sharing electrons equally. Over here, they're pulling on the electrons more strongly than carbon. So in a sense, they're kind of gaining electrons in the form of a nonpolar, or in the form of a polar covalent bond. Does that make sense? So yeah, oxygen gets reduced, carbon gets oxidized. So here you have electrons that are high potential energy going to lower potential energy. And this combustion reaction is a violent reaction that releases a lot of energy in the form of light, heat, and sound.
High entropy to
No,
No,
on the
low
left is low entropy, moving to high entropy on the right.
okay. Right.
Our products are always higher than.
It depends. If the product is higher entropy, then that means that this is an exergonic reaction. And this is an exergonic reaction. All you need is just a little bit of activation energy, and this reaction happens and releases energy. If we wanted to go the other way, and we take carbon dioxide and water and turn them into this, these are lower energy, these are higher energy. So that would be an endergonic reaction. That would be high entropy to low entropy, which means that we have to put energy into the system in order for this reaction to happen.
How do we know which is more stable?
Which
More
is more
disorganized.
stable? The side with non-polar covalent bonds is the more unstable side. So the side on the left is all non-polar covalent bonds, unstable. The side on the right, polar covalent bonds, stable.
Ooh.
The reason they're stable is because those electrons don't react as well, because they're strongly associated with an atom. It's hard to get these electrons to react because they're strongly associated with an atom. These electrons, it's easy to get them to react because they're not closely associated with one atom, so they're easy to move around. The easier it is to move an electron, the more unstable the molecule. Because if an electron moves, the molecule gets destroyed or changed. Does that make sense?